Today we're going to talk about developing whole number operations with mastering the basic facts. It is assumed you have basic addition, subtraction, multiplication, and division. We're going to discuss all of these operations over the course of the next week, and we're going to talk about how they relate to one another. Keep in mind that the NCTM teachers, National Council for Teachers of Mathematics, help students learn their basic facts by having students model and discuss the relationships between numbers. So just as we've been working on in class, talking about the relationships between numbers, we're going to continue this as we move into whole number operations. So what is fluency? Fluency is the connection between conceptual understanding and computational proficiency. And computational fluency is the connection between conceptual understanding and computational proficiency according to the NCTM 2000 standards. Fluency includes the deeper understanding of concepts and flexible, ready use of computation skills across a variety of applications. So when you were in school, what did you think of when you heard the word fluency? Just kind of keep that in mind as we go through and we actually talk about the next few concepts with basic facts. Now, traditionally, basic facts are what we refer to as your basic addition, subtraction, multiplication, and division facts. These are also known as the single-digit combinations or basic number combinations. And so they're really not using that terminology of basic facts as much anymore, but you still need to understand what we're referring to when we say single-digit combinations or basic number combinations. So some facts are committed to memory while others are figured out using a step-by-step procedure. Single-digit combinations are those needed to figure out all the others. So they are the basis for the rest of the facts. There are three things children should be led to do in order to learn all single-digit combinations. One, the children should discover the answers for themselves. So are you giving them time to look at the activity, play with manipulatives, and see if they can come to the answer themselves? Or are you just telling them that 7 plus 9 is 16 and expecting them to memorize that? Two, the children should recognize relationships that exist among the facts. So if you're helping your students to discover the relationships that exist among the facts, this is going to improve their retention of facts, and it's going to reduce the amount of memorization needed. And thirdly, the children should commit the facts to memory. So you're not just going to tell them that 7 plus 9 is 16, 9 plus 7 is 16, and expect them to remember that. You're actually going to help them to discover those answers and create relationships so that they understand and commit those facts to memory rather than just using rote memorization strategies. So those basic facts or single-digit computation there's a variety of them for both addition and subtraction. So for subtraction, you have the inverse of the addition facts. For example, 16 minus 7 is 9, but we also know that 9 plus 7 is 16. 14 minus 8 is 6, but we also know that 6 plus 8 is 14. So for subtraction, there's 121 single-digit computation problems or basic facts for subtraction. Also remember that in division, the opposite or the inverse of division is multiplication. And there are 110 basic facts for division because there are not facts with zeros as a divisor. So if we go back to the previous screen and we look at the multiplication, multiplication and addition involves all combinations of whole number add-ins and factors from 0 to 10. But with division, 0 divided by 5 is just going to be 0 because 5 cannot go into 0. So there's only 110 basic facts for division because those facts because there are no facts with zeros as the divisor. Also remember that there are only 11 whole numbers between 0 and 10. There are a total of 242 combinations for both addition and multiplication. So you need to consider this as you're working with your children and they're learning all of these single-digit combinations. So to teach your students mastery of the basic facts or single-digit computation, we have a three-step approach to fact mastery. We have first, the children must understand what each operation means. Secondly, we use thinking strategies called mental strategies that can be used to relate known facts to unknown facts. For example, if children know what 2 plus 2, that 2 plus 2 equals 4, the one more than thinking strategy would help them to determine that the sum of 2 plus 3 must be one more than the sum of 2 plus 2, or 5. So we're going to really look at some of those strategies that can help with the counting strategies that we did previously, so the doubles plus one, the counting on, just some of those strategies that they really need to learn as they're learning their basic facts. Thinking strategies help children find the answer to basic facts problems without using concrete materials, by providing structure for organizing facts so that recall is easier. Okay, so your goal is to help them use those consolidating activities so that those fact recalls are easier and they have a strategy to depend on. Step 3, consolidating activities could come in the form of games, worksheets, and other activities that give children opportunities to practice facts that they are learning in order to memorize them. So remember that drill and practice are most effective. As you're looking at what your students need to know or they should know, keep this in mind as we're looking at Georgia standards. In kindergarten and first grade, addition is putting together and adding to. So the key words that you'll use with your children in kindergarten and first grade for adding is putting together and adding to. You need to know those two terms. For subtraction, your students will take apart and take from. So you need to be very consistent in what language you use, because that's the academic language of mathematics in kindergarten and first grade. So we're putting together and adding to for addition, and we're taking apart and taking from with subtraction. In first grade, as I said, you're still putting together and taking apart, but you're also going to be moving toward that fluency in second grade. In second grade, you'll begin laying the foundation for multiplication and division. And then in third grade, you're going to be making equal-sized groups or arrays and area models. Your students are going to be moving toward finding unknown products, division, finding unknown factors. In fourth grade, your students are developing understanding and fluency with multi-digit multiplication, developing understanding of dividing to find quotients involving multi-digit divisors. And then in fifth grade, you're going to extend the understanding of division to two-digit divisors. So it's important for you to understand what's coming to you as you're learning how to teach each of these strategies. You need to know what the students have previously learned, as well as where they're moving toward, so that you have a solid understanding of how you can help your students. As you begin the developmental sequence for addition of whole numbers, you're really going to work with your students to develop the meaning of addition. Okay, so as I said earlier, we are putting together and we're adding to when we're talking about addition. We're also combining quantities, and we can count to find the answer. So you want to associate that addition with combining, putting together, and adding to. So this association should be so strong that when children see 3 plus 4, they visualize 3 things being combined with 4 things. When seeing a situation where quantities are being combined, the child thinks, oh, that's addition. And you're going to give them a lot of opportunities with this, which we'll talk about in class. For developing sequence for subtraction of whole numbers, remember you're using those terms taken apart and taking from to help them